Welcome to question 5 from the 2020 TMUA paper 1. The question tells us that the curve S has equation y equals px squared plus 6x minus q, and that it has a line of symmetry at x equals minus a quarter. We are also told that it touches the x-axis at exactly 1 point. Using this information, we're asked to find the value of p plus 8q. We are given the options 6, 18, 21, 25 and 38. Pause the video here and have a go at doing this question for yourself. Okay, well, from the equation we're given for S, we can see that the curve is a parabola. So let's just draw a general parabola. And we're told that it has a line of symmetry at x equals minus a quarter. So what lines of symmetry does this parabola have? Well, we can see that it just has one line of symmetry which comes vertically through its turning point. Okay, what else are we told about S? Well, we're told it touches the x-axis at exactly 1 point. So what does that tell us? Well, a parabola that only touches the x-axis at exactly 1 point must have a exactly one root, and that tells us that the root must therefore be a repeated root. And when we have a repeated root, that means that we have a turning point at the x-axis on the root. So this tells us that the line of symmetry, which is x equals minus a quarter, passes through the turning point, which is the root, and that root is repeated. So all in all, this information tells us that this equation, or this expression on the right-hand side, has two factors of x plus a quarter, because minus a quarter is a repeated root of this expression. So we can therefore write down the equation for S as some constant times by x plus a quarter squared, because we know that it's a quadratic expression, but we don't know the coefficient of x squared, so we're just going to call it some general real number a. And now if we expand that out, we get a times by x squared plus a half times a times x plus 1/16 times by a. So this is the equation for S, but we've already been given the equation for S in the question, which is px squared plus 6x minus q. So now what can we do? Well, we can equate the coefficients, because these two expressions must be exactly the same, because they describe the same curve, S. So we see that a is equal to p, a half a is equal to 6, and a 16th a is equal to minus q. And now using this information, we can solve for p and q, and therefore find p plus 8q. So how can we solve this for p and q? Well, the fact that half a equals 6 tells us that a must equal 12. A equals p, so therefore p equals 12. And q is equal to minus a 16th times a, if we move that minus 1 onto the other side. So q is equal to minus 12 divided by minus 12 divided by 16. And we can simplify that fraction to minus 3/4. So p is 12 and q is minus 3/4. And the question asked us to find p plus 8q. So if we substitute in the value p equals 12 and q equals minus 3/4, this is 12 plus 8 times minus 3/4, which is just equal to 6. And if we look back at the options at the start of the question, we see that option A was p plus 8q is 6. So the answer is option A.